Bright Tuty. Every student matters.
Let us now practice little question to see what we have learned. The question says, draw a rough sketch of a quadrilateral PQRS. Draw its diagonals, name them, and then the question says, is the meeting point of the diagonals in its interior or exterior of the quadrilateral? I hope you remember what diagonals are, right? Now let's go step by step. The first thing it says that draw a rough sketch of a quadrilateral, and we have the name here is PQRS. So let's do this. So quadrilateral can be any shape. It just needs to have 4 sides. 4 straight line segments. I'm sorry for these curved lines of mine. Okay, so just imagine this as a clean line segment, like a figure which is made up of straight line segments. Okay, so this is a quadrilateral and the name says PQRS. I can write the name starting from any point. I can start from here, I can start from here, I can start from any point. I'm going to start this time from here. P Q R S. Okay, I have made sure that I'm writing these letters in a particular manner going round the shape. Okay, I cannot jump to the opposite one. I just have to go by the adjacent points all the time. Now they're asking you to draw these diagonals in this particular shape. So let us see how we can draw the diagonals. I hope you remember that diagonals are drawn by joining the particular point to the point which is sitting next to the adjacent point. So to this point Q, R is sitting in the adjacent place. So let us join to the opposite point, that is S. So QS is one of the diagonal of this quadrilateral. Similarly, let us draw the other diagonal, that is RP. So now they are asking you name them. Okay, so let us write the name of the diagonals. So here we have diagonals SQ and RP. So these are the 2 diagonals. Now they are saying, is the meeting point of diagonal? Let's name this point as well, where the 2 diagonals are meeting. Let's name it as point O. Is it in the interior or is it in the exterior of the quadrilateral? Where do you see it is? Of course, it is in the interior region, right? So we learn a thing from here that every time we see diagonals, they meet in the interior of a given shape. Okay, moving ahead. Now here we need to draw a rough sketch of a quadrilateral whose name is given as KLMN. So let us draw it here. As I told you, you can draw any shape for a quadrilateral, but make sure that you are using only 4 sides. It needs to be closed, right? And only line segments you are using to draw it. Now let's name it. It is K, L, M and N. Okay, so KLMN, this is the name of this particular quadrilateral. Now we need to name in the first one 2 pair of opposite sides. So I hope you remember the side which is sitting next to the adjacent one is the side which is opposite. So to the KL side, which side do you see opposite? KL is opposite to the side NM. KL is opposite to NM. Is that right? Now the other pair is, this is one pair of lines that are opposite. The other pair is NK and ML. So NK and ML. This is the other pair that is opposite. Now the next one, 2 pair of opposite angles. So angles that are opposite. Let me just change the color of this here. Just one moment. So this is point K. I hope it's clearly visible. Okay. So this is point K. This is point L, M, and point N. Okay. So we need to name two pair of opposite angles. So here clearly we have angle N, which is sitting in the opposite to angle L. This is one pair. And which one is the second pair? The second pair is angle K and angle M. So these are the two pair of opposite angles. Now talking about two pair of adjacent angles, that is the angle sitting side by side, right? So adjacent sides to the side NK, this is a side who is sitting next to it, KL, or if you want, I can write for the same one, NK, and to NK we also have NM. I hope this is clear. These are the two pair of adjacent sides. You can write more in the same figure. That is if you choose about the line KL. Then you have NK and ML. They both are sitting adjacent to KL. Similarly, if you are looking at ML, then KL and NM, they are sitting adjacent to ML, right? Now the next one is point the D part. Two pair of adjacent angles. That is the angle sitting next to each other. So here starting with say angle L, I can see that angle M is sitting to next to this angle L. So this is first pair, and again I'm choosing angle L to find its adjacent angle. So to this particular angle L, I have got angle K which is sitting to its adjacent. I hope this is clear.